5 photosensors. So when we run our data acquisition program, we'll actually be able to look at the flame speed and the flame intensity. But for today's demonstration, we really don't care. We want to see the boom. Okay, so you'll see some slight flame beginning around the heat source right there. Right now it's too lean to do anything, but as there it goes. So you'll see it there again. You know, it will build up the fuel density in the volume. Right now it's too lean to do anything. There's not enough fuel and air to really do anything with. Once it hits a heat source and the volume fills, you'll see a slight flame begin. And then once it gets to a certain point where it's dense enough, then the fuel will begin traveling. Just like I said, I'll just repeat myself, but then it will accelerate. There's the flame. Right now we're kind of at a stoichiometric ratio, which means we have a good mixture of air and fuel. But we can run it in a lean mixture or a rich mixture. So rich would be too much fuel, lean would be too much air, not enough fuel. So what I'll do is it's kind of neat looking at it in a rich setting. So I will set that. And the frequency will decrease, so it won't happen, the events won't happen as frequently, but when you do, you'll see this ghost flame. There's more fuel, so it will take more time for all the fuel to be consumed because it's tumbling as it's looking for air. There's just not enough air now. So you'll see the flame kind of tumble because it's looking for air. Now one thing also with flame, if you remember looking at the candles, you know, or the fire in the fireplace, it's always going up. Well, flame has a buoyancy, which means, you know, it's just as it sounds. We have some ghost flaming, and if you watch the thermocouples, they'll actually glow, even though visually with your eyes you can't see the flame. But anyway, the flame has a buoyancy, so the heat wants to raise. So the top end of the volume will be hotter, and so you'll see more events occurring at the top. So when you see that ghost flame, you'll see it more at the top because there's more heat, and heat equals energy. Okay, we'll see one more, and there we have some ghost flaming as it's searching for that oxygen. Okay, now to do this lab this is normally a 3-hour segment. Trying to do it in a 5-minute segment is kind of tough, but it's one of our most interesting labs because we are looking at a basic principle which we all thought we understood, but at the end of the 13 weeks in this course, we're able to really define what happens to flame and within a flame and within its environment. So it's actually a really, really exciting program. And then with new fuels, we're actually able, using the bomb calorimeter, we're able to look at how flame is affected by these new fuels. And you know, we're trying to develop new fuels, but we got to make sure they work first. So some of the very beginning testing is occurring in this lab, not in our instructional lab, but in a research.